is Matt Page. I'm at the Mars Space Science Laboratory of University College London, which is a department of UCL, but it's outside London. This is a stand about the Herschel Space Observatory, and the Herschel Space Observatory is that model there. It's a 1/10 scale model of our space telescope, Herschel, which is an infrared space telescope. The primary mirror is 3.5 meters, so it's the biggest mirror in space at the moment. And it differs from, for example, the Hubble Space Telescope, or indeed your eyes, in that it looks in the infrared rather than the visible part of the spectrum, which is where stars emit most of their radiation. So about half of all the light that's come from stars since the universe began has been soaked up by dust. If you stand somewhere dark, not here in London, because it never really gets very dark here, but you look up in the night sky and you see the Milky Way, you'll see dark bands running through that, and those are dust layers in the plane of our galaxy. So the optical radiation coming from stars just can't get through that dust. So the approach that we take is we look at that energy that's been soaked up by the dust in the far infrared. Just as it soaks up the radiation from stars, that heats the dust up until it's re-radiating just as much energy in the infrared, so it's just an equilibrium. So you can see at the back of this stand images taken with Herschel of dark parts of our galaxy, and you see the radiation coming from this dust. The dust is at about 230 degrees below zero, 30 or 40 Kelvin, so very, very cool stuff. So we have to have our instruments even colder than that if we're going to successfully detect that radiation. So the instruments on Herschel are cooled to about 2 Kelvin, and the detectors, the most sensitive parts, are cooled to 300 millikelvin, just 300 thousandths of a degree above absolute zero. And in the infrared, you see these filaments and streams and globules and all this kind of stuff, dust. And in the densest parts of this, that's the regions where new stars form in our galaxy. So in many respects, this is the most interesting bits of our galaxy that you can see. Now, most of the stars in our galaxy formed 7 or 8 billion years ago. So as well as looking at things nearby in our galaxy, we also pointed out of our galaxy where we can look at the very, very distant universe, and that means the distance of the universe a very long time ago. So we're looking at the universe when the stars that we see in our galaxy today were being formed in galaxies, and those galaxies that are forming stars show up as very bright sources of infrared radiation, because when you form stars you have lots of cool gas and dust that's soaking up all that radiation from the stars. So the infrared camera is supposed to illustrate the sort of thing that Herschel does. So it's looking at us in the infrared, so it's basically seeing the energy coming up from us because of our body heat. It's obviously working at a much shorter wavelength than the Herschel cameras. So where the Herschel cameras are looking at something at 30 to 40 Kelvin, we're at 290 Kelvin or something like that, so we have to have a different sort of technology. But this is working in exactly the same kind of fashion.